Now it's recording, right? So just to recap, whatever we have discussed so far, scalars are single features that represent one particular entity, right? And vector is a collection of features that represent or that incorporates multiple features to explain a profile or to represent a profile, entire profile. Fine. And then it is totally different from the physics vector, where we can max at most we can go up to 3 dimensions, but in data science the number of features can be anything, like it can become 100, it can become 150, it can become thousands, no issues. Some databases like Amazon's database and everything, it contains thousands of features. Okay, so that means what? It is a 1,000 dimension vector, right? And then if we connect that with a table that contains multiple data, then each row is a vector, and then each column we can call it as a feature or attribute, right? I will show you a sample data set where you can make more sense of it, right? So this is one kind of representation. And another thing, another word that comes in, profile is a collection of vectors. No, it is not. Profile itself is a vector. One particular person's profile represents his or her vector. Okay. That vector contains multiple features. So profile, you can say it is the collection of features. If I want to describe person A, right? Then what features do I want? Let's say age I want, height, right? Then maybe weight, then maybe skin tone, right? Correct? So what are these? These are essentially the features of that particular person, right? This entire set is the vector for this particular person, person A, vector of person. Does that clear your doubt? Table is known as what? Table is known as table, nothing else. It is the collection of profiles, multiple people, right? If I say I want to describe my students in this manner, right? And then I have the list of students, right? How do I take that into my system? I will create a table, right? The first one will be name. If I want a name, or maybe an ID number, I don't know, right? And then age, and then height, right? And then weight, then maybe skin color or skin tone, right? So all these features, they become the column of the table, and this entire table is my data on my students, right? Where each row corresponds to one student, say, or one person, say person A, B, C, D, and so on, right? Each row is a vector, and for each vector we have these features. All these are considered as, including the ID number and name, they become the features. Fine. Now, if you strip away these things, there are different types of data that we have in data science or in artificial intelligence, because any artificial intelligence model requires data to be processed, because without any data you cannot train a model. You can make the you cannot make the agent or the machine learn what it has to learn, right? Because if you have an AI, how do we actually learn? How do we learn as human beings? We look at the world, we process the data, and we get the information through our senses. We process it, and with that, we draw our inferences. And based on that inference, we make our judgments, right? That is how we learn, right? Essentially, that has to be done with the computer also. That is what AI is. So what does AI do? Basically, just to make you understand why this is relevant, right? An AI system, what it does, it is first it collects the data, right? And after collecting, it has to analyze the data, right? Before that, actually, we have another process, that is understand the data. We can explore that later. Understand data, and then it has to analyze it, right? After analyzing, draw conclusions, or we can say learn. Based on that learning, it has to predict, right? And generally, whenever this happens, based on the prediction, we will again go back collect more data, understand it, analyze it, then learn, and then predict, right? So this is generally the life cycle of any AI system. So if you look at this entire process flow, you will come to know that first we will have to collect the data. How do we collect it? This is where these kind of tables come in, right? From maybe from internet or from through a format that we provide. For example, I provided a Microsoft form for you to enroll, right? So something like that maybe, or we do a survey and then enter it into a computer system, or we have something typed in an Excel sheet. All these things are the ways we can collect data, and that data has to be treated in this manner. How we understood what is a vector and what is a feature, that is how it is. It is structured. All right. So that is one way of doing it. That is one kind of data. Another kind of data that we call, one is structured, that we saw now in a table format, right? Again, it is gone, is it? It is getting disconnected again and again. One second. Sorry. Yeah, right. Structured, if it is in a table format in a proper way, then it is called structured data. Unstructured data is another type, right? Is generally in another format called matrix format. The simple difference is, in structured data, something like this, the features are marked. Every column is assigned with a feature. But in an unstructured data, it is simply a matrix, something like this. It also contains rows and columns, but those rows and columns, they do not correspond to any particular feature or attribute, right? The entire data, whatever the numbers that we have inside this particular grid, then the entire thing represents something, just like that, right? Say for example, I have some 0 1, some 100, 255, and 0 maybe, right? 0 0 0 0, right? And then 255, let's say. I'm writing something intentionally, right? I'll show it to you when we do the demo, right? This also, let's make this top row as zeros, right? This particular grid that I am showing you right now, this is an unstructured data. If it is an image, for example a photograph, if it is a single monochromatic image, what we say grayscale image, then this image is going to look something like this, right? What is this? The borders where we have zeros is going to look black, and the middle part wherever there is 255, it is going to look white. Okay. So this also represents an image. It is also a data. It also contains some information, but it is not the each row and column is not associated with any different feature. Neither it is related to different features, nor it is related to different people or profiles. The entire thing itself is representing something. This is another kind. Fine. This is an example for structured. Make sense? Yes or no? Either reply through chat or unmute yourself and tell me. No, it doesn't. Whenever we say a table, the table must have headers, right? Those headers or the headings will not be present in an unstructured data. Okay. If it is an image, I have taken the simplest example. It is an image. If it is an audio file or a video file or something else, right? In those situations, the same thing, but the format will be a little different. If it is an audio file, we call it as a time series data where time also matters. In an image, it will not arranged into rows and columns. It will be for an image, it will be for an audio file, it may not be, right? For an audio file, generally it will be something like this. It is a stream of bits or numbers, right? Because the audio has to be played sequentially, right? With respect to time, it has to move. In that situation, this will be something like, if it is a single tone, maybe I'm just take don't worry about the terminologies, right? If it is a single frequency sound, something like 0 1 2 3 4 5 6 7 8 9 10 11, it will be played out in a manner that the volume, if I plot it something like this is time, and this is volume. If these values represent the intensity, then the intensity is going to rise like this with respect to time. After maybe 5 seconds, 0, 1, 2, 3, 4, 5, the volume will be at 4 level. Okay. Just don't worry about this. We will not be looking at this time series data in this course anyway. I'm just trying to explain how these things are managed in computers. This we will see a representation, and also you can call this as matrix, right? If you want to consider or look at the similarity between two images, and those things will come into effect here inside matrix. We'll talk about it later tomorrow again. Okay. So any other doubt? Nothing? Shall I continue? Okay, fine. Um, now let me just tell you programmatically. Uh, Let me keep it shared. It may go away. I don't know. I will share the Google Colab. I hope you guys also have Google Colab, right? Just open that. I'll stop sharing this one notebook. Yeah. Do you guys have Google Colab open? Are you able to do that? Okay, cool. Now we have seen how those data are represented theoretically, right? Now let's see how we can do that with respect to the programming that we have to do. So we are going to use Python, obviously, right, which is very flexible for data processing and everything. And the thumbs up language for AI programming, whatever it is Python, because of the widely available libraries, the models, the open source platform, and everything. It's really nice, right? Now, for the representation of a scalar, right, we use something called a variable. Basically, how do you declare a variable? Some name equal to some attribute. That's it, right? So if I want to print it, just to make sense what is inside A, we can see 40. This is basically a scalar. However, if I want to represent a vector, then I will have to make use of a list, right? That makes more sense, or a couple or something, some collections data set we will have to use. Then if I print vector, sorry, it is going to throw some error. So the below one is a vector and the top one is a scalar. This is the basic understanding that we have. If I want to represent, say, some multidimensional data and multidimensions, multiple vectors, if I want to represent, then the best thing that people will think usually is to use a list of lists, right? But we should not do that. Instead, in Python, there is a library called NumPy. Okay, this actually stands for numerical Python. Generally, if you are getting into any data science or AI, machine learning, whatever it is, you make use of NumPy library. Okay, why NumPy? Why can't I represent a vector using this simple list? Because internally, NumPy uses a different kind of memory allocation compared to a list. Okay, Python generally, whenever you create a list, uses linked list in the background. So the data that you have written here, 1, 2, 3, 4, 5, are stored in sparse locations. Like wherever there is a space, it will allocate that memory, store the value, and link it with the linked list. However, in NumPy, whenever you want to declare something like this on an array like object, then generally continuous memory locations are allocated. So if I want to access this particular array or a vector, the access time period will be much lesser. So it is going to be more efficient, right? That is that is why generally we make use of NumPy. How do you make use of it? First of all, you will, in any Python program, you will have to import it. So import NumPy, as the general name that people use is NP, so that it makes easier to type, right? Every time you want to make use of it, typing NumPy is a little lengthier compared to NP. That is why this is the standard name that is used in the industry. Okay, you import NumPy as NP, and then creating a scalar in NumPy is something like this: A is equal to NP dot array, and then you pass in one single value. Okay, may throw. Okay, fine. Now, if you print it, you'll get the same value. However, one specific difference is if you try to see the type of A, it is going to be a different object. Fine. The type function gives you what kind of object it is. Now, if you want to see this, a general variable is different compared to this. Let me show it that to you as well. Right. Say let me take another name. B is equal to same value 5, and then print B, right? And then let's print type of B. As you can see, the above one which used the numpy array is coming through as numpy dot nd array, and the second one B variable coming through as int, which is a basic variable. Okay. Now, for a scalar value, it doesn't make much sense anyway, but it's good to know what is the difference. All right. Now let's create a vector, right? If I want, can we take some example? Say BC or vector 1 is equal to, how do you declare a vector? The same way, array. Here you will have to pass in it as a list or a tuple, something. Better to use list, right? Now if I print it, then let us see this first. So it is simply coming through as a basic list, right? Just like that, let us print this out. See, numpy dot nd array. This nd array basically stands for n dimensional array, nd array in numpy. Okay, so this is one way of representing the scalars and vectors. Fine. Do you have any doubt regarding this? Just put it in the chart or something. Okay, it's clear. Fine. How many of you have actually used this one? What is that? NumPy so far? Nobody? NumPy has some really nice functions. If you want to see what are the functions available, np dot, you press it, you can see so many functions available here, right? Tan function, including the mathematical functions, whatever are there. Many functions are available, including the trigonometry functions, exponentials, floor functions, right? All those things, they are there. Uh, However, most of the times, uh, even NumPy is not sufficient for us. In that situation, we go for another package called Pandas. Okay, we will talk about Pandas and everything in the later sessions. Whenever, however, I just want to show you something. So let me do that. So in Google Colab, few things to remember. One is whenever you type something, right? If you want to execute that, either you can press on this play button, okay, or you can press Control Enter. Hold down Control and press Enter. You'll see the output. Fine. The best thing about Google Colab here is it is a notebook system where every cell's output will be displayed right next to it. Okay. And then if you want to create a new cell after this one, you have some code here, and then you want to create a new cell to execute something else, then all you have to do is to click here, press Shift Enter. Shift Enter, what it does, it actually executes this cell and then creates another cell, and your cursor moves to this. Here you can continue executing. Okay. Uh, Whatever you type in the previous cells and run them, only those things are available to the next cell as well. For example, here we have created A, B, and then vector 1, right? All those things are available here also. If I type A here and press enter, control enter, I'll get to see what it is. Fine. This is one more feature that is available with any notebook types, notebook interfaces, that the last thing that you write, its value, whatever it gets evaluated to, that value will be displayed by default. You don't have to put a print statement to that. However, it is always better to use a print statement because it only happens in a notebook environment, not in any common script. Fine. Okay. So right now I would like to show two more things. One, I have a sample data set here just for you to make sense of whatever I said in the theory part, right? So let me import pandas as PD. This generally PD is the short form used for pandas library, extensively used in data science, right? Then there is a function called if I call this as data, right, equal to. Don't worry what I am doing. If you can't make sense of it, it's fine, totally fine. We will look at it and I'll explain it properly in the later sessions. Read CSV, right? I have a data file here, right? Admission code predict one dot CSV, right? If I display this, now you can actually see how a table is formatted in a structured manner, right? This is the row number. Don't worry about it. Now you have serial number as one feature, GRE score, TOEFL score, university rating, right? SOP, LOR, CGPA, research, and everything. So these are the features for every individual candidate here in this particular data set. Can you see how structured data looks like, right? However, if I do the same thing, let us say let's create an array. I just wanted to show you an unstructured data as well. So let me create amg array is equal to np dot array. Let's create a matrix inside. So for the first row, let's put 0 0, sorry, 0 comma 0 comma 0. I think I have it somewhere around here. Hold on. Okay, no issues. Let's type it out, right? Let's put one more value here. First one was 0, then 255, comma 255, comma 0. This same thing, let's copy it for one more row. Sorry, two more rows. Yeah, the last one, let's copy this, right? So this array we created. Let's just look at how it looks like. IMG array. So this is how it is looking like, right? Something similar to what I had written previously. Now let's display this particular array as an image, right? Just to show you, import SPLT. Yeah, right. Let's, what was the name I had given? IMG underscore array, comma CMap. Yeah, can you see this? So the zero values that we had put in the surrounding areas, right? They are treated as the black border here, and the middle 255, 255, 255, 255 is looking like white patch in the middle, right? So if you feed a grayscale image into this particular program, generally, whenever you want to incorporate some image into a program, this is how this is how it is essentially converted inside. Maybe in the next class we can take a proper gray color image, load it in, and then we can see the matrix as well. Fine. If you have any doubts, you can ask away. I hope you guys are also trying it out. All of you got the output. Don't worry what these things are, right? All right. I will explain these things like what is matplotlib.pyplot. These things we will, as and when it is required, I will explain these things to you. This is also another module which is used for plotting in Python, right? And IMShow is one of the functions which can actually display any array as an image, a two-dimensional array. Only 2D is possible. And then 2D in the sense two-dimensional matrix. Okay. And then this is to keep the names X and Y axis names as nothing. And then plt.show shows the image. If you don't put this, sometimes it will not be shown in a normal script. It will not be. However, in this Google Colab notebook and everything, it will be shown by default. So here, even if you forget this, you will get the output. But the best practice is to use this particular function. Anyway, so I hope this much you understood. Why don't you guys unmute yourselves and tell me what is going on and are you able to get the output or not? By using the library, we are going to learn, sir. Is this a question or what? Okay, by using this library, are we going to learn, sir? Let me take this as a question. Yeah, NumPy and Pandas are going to be our friends for the rest of the course. Okay, these are not libraries like we will not do something like any AI algorithms and everything, right? They require a representation, and those representations are better done with the NumPy and Pandas. These are the thumb rule libraries that we will have to use. These are only tools to represent the data, but this course is not about NumPy or Pandas. You will get plenty of courses in YouTube for Pandas and NumPy. So we are going to cover the mathematical basics. Today is only about how we are going to uh, or what we need to cover the mathematical basics from the next class. Right. Today we covered, let me recap whatever we have covered. We have covered what is a vector, what is a scalar, and then generally what does a matrix mean, and what is a structured data, what does a structured data look like, and what it is, right? How is the relation of vector and scalar concepts in any data set? This we understood, and then um um, the different types of representations of data we covered. So for today, only this much is what I'm going to cover. If you have any doubts, you can ask away. However, from tomorrow onwards, tomorrow I'm going to cover the linear algebra basics. Uh, right, and what is the relevance of vectors and scalars in linear algebra? We will understand that. And then maybe day after tomorrow, if everything gets completed in tomorrow's session, we will start with the stats part. For all these things, however, the implementation part will require NumPy and Pandas. That much is for sure. Yeah. So Kishore Gowda asked other things also you going to cover. That's what it is. Right. The course is about mathematics, not NumPy and Pandas. Any other doubts? Nothing? Please ask your doubts in the chat, or at least in the chat you can ask, right? I would prefer asking directly, but if you're not in a position to do that, you can do that in the chat. I'm waiting for your input. This is the scariest part of any class, online class, people not talking back to you. And by the way, how I incorporate different data into my program when I'm executing something, I'll just explain it on the like second second. I am unable to understand what you are trying to ask, man. Kishore, you will provide the project also, no, sir? You, sorry. Okay, I don't know. Maybe it is an auto type error. You will guide or you will provide the source code. This is what you are asking, I hope. Yeah, right. See, project in the sense, whatever we learn in the mathematical foundations, we will do finally in the end, we will be developing a predictive model. The basic of all the models that are available in AI, linear regression model, we are going to build on a particular data set. On any data set we can take. Okay, I will find a really good one and we can do that. For that, the last 1 or 2 sessions will be dedicated to that. I'll be guiding you, live coding you how to do that, right? You will have to follow with me. And finally, we will do that. And unless everyone gets the output that we are supposed to get, I will not stop. Maybe even if it takes one more session, I'll do that. Okay. However, the mathematical foundations are the core focus here. You will have to understand the concepts that I'm going to explain in the subsequent classes. How it is linked with the actual field is the icing. That's all. Last linear regression model that we are going to build is going to be that. Okay, because obviously, okay, probability, the mean, median, and mode, and those values, how are they going to help me with respect to AI? That will be the big question, right? So that I just want uh, you to have that feeling that okay, this is how it gets used in the field. That is the agenda here. I think I had mentioned that in the orientation itself. This is not a project assistance course. It's that is not the target here. All right. So any other doubts if you have about the concepts that we have covered today? If nothing else, I am going to end the meeting. Okay. Okay, once again explain pandas library. Don't worry, pandas library we will cover it in the subsequent sessions. Whenever we start the stats part, right? Linear algebra, we do not require that. We will declare our own arrays and everything using NumPy, and um, so that is good enough. However, the moment we move into statistics, right, we will require more data to calculate the mean, mode, whatever it is, all those things. We will require a larger data set. So that is when the pandas comes in. I will explain everything over there regarding pandas, because in pandas also you have two types of data representation. One is called a series and another is called a data frame. What is a data frame? What is a series? All those things I'll explain during that, and the basic syntax and everything I'll explain. Okay, don't worry about it today. So today's agenda is to understand the data representation. What are the different types? Vectors, scalars, matrix, and a table, right? How it is represented in Python. How do you do that? That much, if you have understood, that is good enough for today. The only reason why we are using NumPy, not a general collection data type like a list or tuple, is because the memory allocation and optimization issues. NumPy is comparatively much more faster, and a huge data set like thousands of records, thousands of vectors, and then maybe hundreds of features. If it is done using a list of lists, then it is going to crush your system like nothing. That is why we go with NumPy. And Pandas is actually based on NumPy itself. Underlying data structure the Pandas uses is basically NumPy. Nothing else? Shall we end the meeting, or 7 more minutes we have? And one more thing, please try to be in a place where you can actually talk back to me. And I am teaching in English, like I mentioned in the orientation. You can ask your questions in Kannada also. So don't worry about the communication gaps, right? No doubts. Shall I end the meeting? Okay. So from tomorrow onwards, it's going to be at 7 p.m. Today I was actually out for some reason and got back late. That is why I scheduled it to 7:30. Uh, Tomorrow, please be ready at 7. We'll start at 7. Right? Thank you.